Hi, my name is Aaron. I'm the project manager for Level 7 Engineering, and we are here to present you guys with our design for the STSU Evolve Plaza del Sol project. To get started, Abdullah can walk you through the geotechnical aspects.
Hello, my name is Abdullah. The existing soil was a major focus because it was undocumented and dated back to prehistoric geologic conditions. To better understand the site, a total of 21 borings were completed for the overall project, with three of those borings used specifically to evaluate Plaza del Sol area. After further testing, the existing soil was determined to be unsuitable for direct fill or foundation support. Because of this, the previous soil was engineered and improved to meet the project's design requirements. The improved soil achieved a friction angle of 38 degrees, cohesion of 350 psf, and allowable bearing capacity of 6,000 pounds per square feet. The fill material also showed very low expansion potential, which helps reduce the risk of future soil movement. Groundwater was not encountered during the investigation, which was also favorable for construction. Throughout the construction process, the engineered fill was closely monitored and tested to confirm quality. The fill achieved approximately 90 to 95% compaction, helping provide a stable foundation system and long-term support.
Hi, my name is McCain. We focused on making sure that our strategy was based on a combination of hydromodification management and water quality treatment, with drainage divided to respond to the site's constraints and existing infrastructure. Runoff from the right side of the site is managed via surface drainage, while the left side is collected through a storm drain system that conveys flows to an underground detention vault, which then goes through a modular wetland and is outletted into the sidewalk and public waterway. Some key design considerations were compliance with hydro modification requirements, water quality treatment standards, and limitations of the existing downstream infrastructure. Going on to our site sections, you can see how we focused on making sure that the water drains away from the building to prevent flooding and damage to the proposed amenity building. You can see the existing drainage, and most of the water flows down to this corner of the site right here, as well as downhill from the existing driveway. And on our proposed site, the water will be draining through the fire access road along curb and gutter, as well as down the side of the site, and will be caught either in this detention vault or surface draining off into the public road. Moving on to the building design, I will hand it off to Mia.
Hi, my name is Mia, and we chose to use steel framing. There were a few reasons behind this decision, merely faster construction, lighter weight, and a higher strength to weight ratio compared to other materials like concrete or wood. If you look at our building design, you can see the use of columns and beams to create a clear structural framework. The loads from the building are transferred through the steel beams into the columns and then down into the foundation system. For our foundation system, we went with slab on grade, and this was our layout. These are our building elevations. So the wings are 12 feet with 10-foot ceiling drops. And then our main room is 22.5 feet because we have a 6-inch slab in between the first and second floor. In the roof plan, we also incorporated trusses, which help span longer distances while maintaining structural stability. These are some of our details. Overall, steel was the best choice for our project because it combines efficiency, strength, and flexibility in our design. I'll pass you over with the swamp and hydraulic calculations to Jose.
Hello, my name is Jose Gutierrez. Provides an overview of our storm water quality management plan, along with the supporting hydrologic analysis for the project. On the left is the swamp cover sheet, which identifies the project and confirms compliance with stormwater regulations for a prior development project. This document outlines how runoff will be managed to protect water quality and ensures that the design meets regulatory requirements. On the right, we have the pre and post-project hydrologic calculations. These results show that the site's runoff characteristics change after development. The impervious area increases from about 80 to 87%, which is expected due to the added surfaces like pavement and structures. Normally, this will increase runoff, but our design incorporates mitigation measures to control it. As a result, as runoff coefficient remains constant at 0.85, and the peak runoff stays the same at 2.84 cubic feet per second. This demonstrates that the project successfully maintains pre-development runoff conditions, which is key goal for both regulatory and compliance for stormwater management. I will pass it on to Isabella with street.
Hi, my name's Isabella. One key Considerations for the Plaza del Sol redevelopment was minimizing impacts to the surrounding ecosystem and protected species. As shown here, the California nutria was identified as a sensitive species within the project region. Because of this, environmental review and compliance were important throughout the planning process. Our team considered measures such as limiting disturbance to nearby habitats, controlling construction noise and dust, and implementing erosion and sediment control BMPs to reduce the impacts during construction. Overall, the project was designed to stay compatible with the surrounding environment while supporting campus development goals. For utilities, we evaluated the existing infrastructure surrounding the site, identified the major utility providers and services that would be affected by construction. This included water, sewer, storm drain, electrical, gas, and telecommunication utilities. Based on the utility investigation, several systems would require protection, relocation, or temporary rerouting during construction activities. From the water and stormwater perspective specifically, protecting existing sewer and storm drain infrastructure was critical to prevent service interruptions and avoid potential environmental contamination. Coordination with the City of San Diego and utility agencies would also be necessary throughout the construction to ensure compliance and maintain emergency access. For flood considerations, we reviewed FEMA flood hazard mapping for the SDSU project area. The site is located within an area of minimal flood hazard, meaning it is outside the major special flood hazard zones. Although the flood risk is relatively low, stormwater management still remains an important design consideration because of urban development increases runoff and can impact surrounding drainage systems. To address this, the project incorporates stormwater BMPs and drainage improvements intended to manage runoff quantity and quality, reduce localized ponding, and support long-term site resiliency. Lastly, sustainability was a major focus of the project with a goal of achieving LEED Gold certification. This reflects the project's emphasis on sustainable site development, water efficiency, energy performance, and environmental quality. From an environmental and water discipline perspective, this includes strategies such as efficient water use, stormwater treatment measures, and environmentally conscious site planning. Overall, the Plaza del Sol redevelopment aims to create a more sustainable and resilient campus space while balancing environmental protection, utility coordination, and long-term resource efficiency. And now I'll pass it off to Roberto with construction.
I'm Roberto Mejia. For site logistics and safety, our team focused on keeping the job site organized, efficient, and safe while working within an active campus environment. We planned areas for staging, access points, fencing, emergency routes, and equipment locations to help construction operations run smoothly and reduce disruption around the site. We also created a safety plan that focused on hazard awareness, PPE, toolbox stocks, fall protection, and emergency preparedness. Lastly, I put together a conceptual cost estimate that included major project items like site work, concrete, structural materials, roofing, labor, and equipment costs. The estimate gives us a realistic overview of what a project like this could cost using quantity takeoffs and industry pricing assumptions. Thank you.